All right, we have example 2. We have solution like this. Example 2 says a hydrocarbon X has relative molar mass of 56 and consists of 87.8% by mass of carbon and 12.2% by mass of hydrogen. Determine the empirical formula of X and hence give its molecular formula. So we are looking for the empirical formula, and as well we are looking for what? Molecular formula. All right, so we are talking about hydrocarbon. Hydrocarbon is a compound that consists only of carbon and what? Hydrogen. So we have carbon like this and we have hydrogen. They say that the percentage abundance of carbon is what? 87.8. Why that of carbon is what? 12.2. Can you see that? All right, what do? We divide this by the atomic mass of carbon. We know that atomic mass of carbon is what? 12. Why the atomic mass of hydrogen is 1. All right, when 12 divides this, we don't have much space here. Let me continue over here. But when 12 divides this, it will give us 7.316 like this. That is for carbon. And when 1 divides this, it will give us 12.2, because anything divided by 1 is itself. All right, when you have something like this, you use the smallest one to divide through. That means that we are going to have 7.316 divided by 7.316. Then this one should be 12.2 divided by 7.316. Remember, at this point, you are approximating to the nearest whole number. So when this thing divides itself, it gives us 1. And when this divides this one, it's going to give us 1 point something, which when you approximate, you are going to get what? 2. So the approximate ratio is what? 1:2. 1:2. All right, it simply means that carbon is 1 while hydrogen is what? 2. All right, so that means that the empirical formula is equal to, we have carbon 1 and we have hydrogen to be what? 2. Can you see that? That is how this can be solved. All right, the next one we have is finding the molecular formula. Remember, they told us that the molar mass is what? 56. So this empirical formula, you put it in a bracket like this. You write N here, equate it to be what? 56. That is the molar mass. Can you see that? All right, the atomic mass of carbon is what? 12. And we have 1 atom of what? Carbon here. So it should be inside the bracket, write 1 times what? 12. Plus the atomic mass of hydrogen is 1, and we have 2 atoms of hydrogen, so it should be 2 times what? 1. Then you have your N like this. Everything will give us what? 56. Can you see that? All right, 1 times 12 will give us, we have 12. 2 times 1 will give us this. Then we have like this. Then everything should give us 56. When you add this thing together, you are going to get what? You are going to get 24, and you're going to get 14, not 24, 14. So this will give us 14. We have like this, 14n like this equals to 56. Opening this bracket, you have like this. Can you see that? All right, so you divide both sides by coefficient of what? N, which is 14. You have like this. You have this. You have 56 over what? 14. Can you see that? All right, when 14 divides itself, it will give us what? 1. When 14 divides this, it will give us this. So you have that N is equals to, when 14 divides this, it will give us 1. All right, when 14 divides this one, it will give us what? It will give us 4. Is it clear? All right, so that means that N is equals to what? 4. Can you see it? All right, so I don't have much space here. Let me continue over here. So I'll clean this one to complete it here. We have gotten the value of N to be equals to what? 4. All right, I will bring this thing back. Where is it? This one. This. So I've gotten the value of N. I will now substitute. I have CH2. I have like this. Can you see? So anywhere I see N, I will call it what? I will call it 4. So here I'll have something like this. I'll have CH2. Instead of writing N, I'll write 4. Right? So remember, carbon is 1 here, while hydrogen is what? 2. So I'll use this to multiply this, use this to multiply that. So that will give me, I have like this. Can you see it? Then this will give me, I have this. Can you see it? All right. So 1 times 4 will give me 4. And I have that here. 2 times this will give me what? 8. Can you see? So this will give me what? The molecular what? The molecular formula we are talking about. Can you see it? That is it. So we have empirical formula to be this, and we have the molecular formula to be this. I told you that empirical formula is when you reduce to lowest term, while the molecular formula will give you the actual value of each content, the atomic content of that compound. All right, so that is it. Remember, this is Engineer Kenneth tutorial. I believe that you enjoyed the way I just solved it. Follow this page and share this video so that it will get to the right student that needs to acquire this knowledge. Bye.